So, you want to learn astrophotography, but you don't know where to start. These rigs are so complicated. There's so many different subsystems that have to work well with one another. What do I do? How do I choose the right OTA? How do I choose the right camera? How do I do all this? Well, that's what we're going to learn about today on another episode of Astro Playground. Stick around. Welcome to Astro Playground. My name is Scott Cole, and I have the pleasure of introducing my YouTube channel to you, our potential new subscriber. I would like to encourage you to watch this video all the way through to learn a little bit about what it is that we're doing here. My personal mission is to be able to explore this amazing hobby in astrophotography. I am a professional photographer that has over 20 years experience in the field of portrait photography, landscape and terrestrial photography, as well as corporate headshot work and real estate. My endeavor here is to explore this amazing hobby in astrophotography. As a photographer, I was looking for a challenge to increase my skills and to grow in the world of photography. When I found astrophotography many years ago, it definitely provided the challenge that I was looking for, even more than I thought was going to be possible. The world of astrophotography can be, as my friends and in this particular field have said, it is a deep rabbit hole. And it can be, at times, very daunting in how to approach it. So we're going to try to unravel a few of those mysteries. We're also going to point you towards some resources that will help you to avoid some of the mistakes that new astrophotographers often can and do make. So let's talk a little bit about what it is that we do here. My personal rig is a C14 that is mounted on a Rainbow Astro RST300 harmonic drive mount that is mounted on a Los Mondi heavy-duty tripod sitting on a JMI wheelie bar that is sitting in my backyard up on its pins. My particular rig is configured in such a way that I can reach in almost 2800 millimeter, 2737 to be exact, which is perfect for deep sky imaging, distant galaxies and such. But I also have a Hyperstar setup that I can image from the front of the rig, which allows me to change the focal length from 2737 down to 720 millimeter. Now, the difference that you have there is basically the going from a very narrow field of view out to a very, very wide field of view. And it also increases the speed or the light gathering capacity or capability of the scope. So at the 2737, which is reduced down from the C14's native 3910, I use a 0.7 reducer, which takes it from f11, I believe, down to f7. And that basically makes it, able to capture images much faster. F11 is very slow. And if you don't understand what I mean by fast and slow, that's a topic that we discuss in some of my other videos. The Hyperstar also will allow us to widen that field out, but it will also speed up the gathering capability. It takes it from f7 down to f1.9, maybe 2, f2. That is an incredibly fast light gathering capability, especially in telescope equipment. The field of view is, as I said, 720 millimeters, so we can capture some wider fields, but we can do it much quicker. What would normally take somewhere in the neighborhood of 3 to 4 minutes, 5 minutes maybe of light gathering, photon gathering into the big light bucket, can be reduced down to 20 or 30 seconds or less. and it's very attractive, especially for capturing nebulae, globular clusters, other wide field subjects, targets. That wide field ability, especially at the fast focal ratio of f2, definitely is very attractive for capturing wide field targets. So we also use different subsystems, and that's one of the things that I want to talk about. The whole rig itself is an entire system in and of itself, but it's made up of many subsystems, and this is where it can get a little confusing for people, and understanding how all of these subsystems work together. All right, what we're endeavoring to do is to capture objects that some of them are bright. Some of them you can see some of those objects on a clear night in a dark sky site. You can see them with the naked eye. You can look up, and if you know where it is, and even if you have a pair of binoculars, like a set of 10 by 50s, you can see the great Andromeda galaxy, M31. You can see it with the naked eye. I've seen Andromeda, with the naked eye in a dark sky site, a Bortle 2 or 3 site. If you know where it is, you can see it. Right? But there are other objects out there that are very, very dim. And even with a scope like the C14, using it with an eyepiece, you would never be able to see those objects clearly. You might get some idea or some hint that they're there, but you certainly wouldn't be able to see them in all of their glory. So we're going to endeavor to talk about the subsystems that make up the system of a full telescope rig. And it doesn't matter what telescope rig you're using. Each one is made up, the whole system is made up of subsystems. And getting those subsystems to balance correctly it's a big part of the battle. All right. So one of the things that we want to look at is the individual subsystem. So you have one of the most important aspects of your subsystems is your base, your foundation, right? The foundation has to be solid. It has to be, unwavering. So what a lot of people will do is they will use very, very beefy tripod setups, for larger rigs. And they will anchor them correctly, or they will weight them down to keep them from moving, right? That's basically what I've done with my rig. I have anchored it, and because it is designed, we originally built it as a mobile rig. So the other way to do it is to put in a permanent pier where you have a concrete pillar, like a large sonotube, a 10 or a 12-inch sonotube that is sunk into the ground, 3 or 4 feet down, 4 feet down, filled with concrete rebar and mounting hardware at the top that will accept a plate that you can then mount you can put a telescope mount on. And of course, that is never going to move, not compared to a tripod. So something like that, but where it has advantages in its stability, it is also permanent. You can't move it. So you can't take it to a dark sky site. You'd have to literally take the mount off and put it on some kind of a different tripod or other mounting hardware, tri-pier or something, to be able to move it. So the base is one of the most important aspects of what we do in astrophotography. Having a good solid pier, tri-pier, or a tripod for your rig is important. And that is actually something that transcends across the wide field of photography and videography. Having a good tripod for your cameras is very, very important. So, and then going from there, having a decent mount. Now, that can run the gamut, of price range. You can spend a couple $100 on a mount. You can literally spend tens of thousands. I have friends of mine that have literally $20,000, $25,000, $30,000 in their mount. A mount like that can be a little intimidating. You don't need to spend that kind of money to get into this hobby. You can start off with a star tracker, you can start off with a relatively inexpensive mount. And again, that's relative term. What I consider to be inexpensive may not be what other people consider to be inexpensive. I think a good place to start with a mount is something, you know, in the range of $1,000 to $1,500 for a decent, you know, starter mount. Now, star trackers, you can get them for a couple $100, but they are going to be limited in what they do as well, and they can and often do work well. But when you start looking at a decent mount, that's where a lot of the attention to detail and your commitment to money should be, in my opinion, should be focused. The ability of the mount to the ease in polar alignment and getting it in a position where it can track not only the movements of the Earth, but it will also respond with other subsystems that tell it to move, to push and pull it around the sky so that it will stay locked on a target so that long exposures are possible. So the next thing to talk about in how to set up a telescope rig would be, what kind of an optical assembly are you looking, you know, to purchase? That comes down to what kind of imaging you want to do. A lot of people will want to be able to maximize the amount of money they're spending. And in doing so, they're looking for something that will be well-rounded, you know, that will be able to give them wide and narrow field of view photography options. So if you want to do something, for instance, that is reaching deep in to look at far distant, very dim galaxies that are a long, long way away, you're going to need something that has a lot of reach, something that will reach into and beyond, you know, 12 to 1500 millimeter. A lot of times that is either a very, very high-end refractor telescope, which refractor telescopes are basically long, they look like camera lenses, huge camera lenses, all right? They're relatively small in diameter compared to, you know, a SCT or a mirror-based rig setup. They are also excellent in narrow field imaging. There are rigs, there are OTAs, optical tube assemblies, that are refractor-based that can reach out 1200 millimeter, 1500 millimeter, but you are talking about an optical tube that is very expensive, all right? Most refractors, you know, are below 1000 millimeter, and they are meant for more of a wide field of view. And then you from there you look at deep sky, you know, where you need to reach in way beyond 1000 millimeter, you know, 1500, 2000 millimeter. That's where you're starting to look at either Newtonians or Schmidt-Cassegrains, SCTs. The SCT can then reach beyond where most, not all, but most refractor telescopes find their field of view. The SCT is excellent for deep sky imaging. It is also excellent for planetary imaging. The thing with the SCT is that where refractor telescopes use lenses, reflector telescopes are mirror-based, hence the term reflector, right? Refractor, lenses refracting the light, reflector, reflecting the light, all right? So an SCT has the unique ability of being able to use the telescope in multiple, or at least two different focal lengths. And that's one of the reasons that I chose to go with the Celestron, the C14, is that I could use it for deep sky imaging, but I could also modify it to put a camera on the front of the telescope, effectively reducing the focal length down, increasing the photon capability, the gathering capability of the scope, how fast it gathers light, but also widening the field of view. I knew that I wanted to be able to reach deep into the sky for distant objects, but I also didn't want to limit myself in wide field shots, you know, shooting the nebula, you know, of the Sagittarius arm, you know, of the Milky Way galaxy. and reaching into that and capturing. So the addition of the Hyperstar for the front of the SCT was an attractive option. There are many options that are available to you as it relates to the kind of telescope that you can build. What I wanted to accomplish was to have a rig that would both function wide field and narrow field. So my focus system, which is the next part of our subsystems in what we have here, is also a very key and important part of what we do in astrophotography. We need to be able to take the rig from a position where it is out of focus and bring it into focus and do it. You can do it manually, but believe me when I tell you, that gets old fast. And it's much better, in my opinion, to not only know, you need to know how to use and focus manually, but you want to have an automated process. And there are software applications that allow you to do that with autofocusers. Now, one of the things that I noticed with my C14 is that the focuser that came from Celestron was adequate, but it wasn't optimal, in my opinion. I needed and wanted an upgrade. I wanted something that was going to work at a better level, and so I opted to go with the Starlight Instruments Focus Boss system, which has their micro focuser and their focus motor that is driven by a hardware and software system that is known as the Focus Boss. And it works very, very well. Running an autofocus routine is a key element in everything that we do in astrophotography. And you want to be able to do that and do that well. So one of the other subsystems that is a part of what we do is a off-axis guider and a guide scope. So guiding with either a small telescope mounted on your large OTA, or an off-axis guider that captures images of stars from the main image coming back to your main camera. So the guiding is another key element, especially in long exposures. Long exposures, to me, anything more than 30 seconds. Most decent mounts will track sidereally with the Earth at less than 30 seconds with no problem. All right. Your higher end mounts, and when I mean higher end, I'm talking about mounts that are, $10,000, $15,000, setups. As long as they are polar aligned correctly, typically on a pier, and polar aligned correctly, a lot of times those mounts, they don't even need guiding systems. They are so precise in their manufacturing that they will track with the Earth and track on your target effectively with no guiding extra hardware or software needed. But for most of us, guiding is something that is necessary. So having a secondary scope or an off-axis guider is another key element. I have both because I can't use my off-axis guider for my Hyperstar. That off-axis guider is strictly for use at the back of the telescope. The guiding from the front of the telescope is done with a William Optics GuideStar 61 paired with a ZWO 290 Mini. That system works very, very well, and I've regularly seen guide numbers that were very, very attractive. 0.4, 0.3. I've even seen it go to 0.2, on real clear nights, which is, that may not mean anything to you, but believe me when I tell you, that is a very attractive guiding number, total resolution. So the other subsystems is the operating hardware and software environments, like the ZWO ASI Air. That little system works fantastic. The only issue with that system is that it only works with other ZWO products. So keep that in mind in looking at that. There are other systems out there that can compete with the ZWO. You can certainly look at doing something with one of those other drive systems. They are a wonderful way of telling the subsystems how to work as a unit within the whole system of the telescope rig. I personally use a system from Prima called the Eagle, which is a full onboard computer. The Eagle is a phenomenal way to control all of your subsystems. It provides power for all of the different subsystems. It provides the computer control through USB 3, USB 2, USB 3. There are many advantages to having a system like that. The one downside is that an onboard computer system from Prima like that typically will run you probably somewhere between $1,500 and $2,300 or $2,400, right, for an onboard computer system like that. They are definitely worth the money. If you can afford it, that would be my recommendation, is to go with something like that. Marrying all of these subsystems together and getting them to work in concert with one another is the goal. Because what ultimately we're trying to do is to point the telescope at a far distant object, because there is nothing up there that is close. And what I mean by close is, the distance, unless of course you're shooting within our solar system, and even then, you're talking about millions of miles. Basically, what you are trying to do is to reach into the far distant sky and capture light from objects that are, in many cases, tens of thousands, even hundreds of thousands of light years from here. So it can be a very delicate ballet to be able to take the scope and point it to an object, using software to resolve on that object according to the position of the other stars, to target on that object, and to guide on a nearby star so that your mount can stay locked on your target, so that 2, 3, 4, 5 minute or more exposures are possible. Because if you move off of that target at all, it's going to create a blurry image. So getting these subsystems to work well with one another is a key element in what we do. So here at Astro Playground, one of the things that we want to do is to provide an environment where a community can and is being built up. We have as of today, we have a fairly good-sized community that is growing, and thank you for all of our subscribers for your patronage. But we are looking to not only grow our channel, but to grow our knowledge base. And doing that together. I will be the first to admit that I don't know everything. In fact, I don't know most things. What I do know, I treasure, but I also try to keep an open mind in the things that I think I know, and not limiting myself by thinking I understand it completely. Keeping an open mind to growing in new understanding as to what I think I know. But also taking what experience that I do have, passing that on to people that are interested in this wonderful hobby. As part of an astro community, we want to encourage people to use the resources that are available not only to us, but we're going to make available to you. To that end, I want to point you to Astro World Web and Astro World TV, as well as Astro World Telescopes. My buddy Dan Higgins, is the owner of Astro World Telescopes, and he, along with myself and Eric Watson and Dave, Super Dave, we have a YouTube channel that in Astro World TV that streams twice a week on Wednesdays and Fridays at 8 p.m. Eastern Standard Time. We talk all things astro photography. We talk equipment. We talk setups. We talk about the techniques. We talk about the principles behind what we do. We are also a teaching channel. So for those of you that are looking to get into this hobby, but you feel like maybe you're dealing with a little bit of intimidation and where do I start? Man, this is a lot of money. I don't want to make any mistakes. First of all, we're going to encourage you that some mistakes are going to happen. What we want to do is we want to mitigate mistakes that are costly mistakes, especially monetary mistakes. How do you choose the right OTA versus, to marry with the right camera? What mount is going to be the best for your particular budget range? All of these things, you start looking at the world of astrophotography, you'll find out very quickly that it is, as I said before, a deep rabbit hole. You can spend, $300-400 on a single filter for your telescope rigs. You want to be well educated in the approach to what it is that we're doing with astrophotography. You want to make sure that the money that you're spending is being spent in a way that's going to produce results. And that's ultimately what we're trying to do at Astro World TV. We are in the process of developing kits for people to look at, within particular budget ranges, within particular target ranges as far as what kind of astrophotography you want to do. Those kits are suggestions to making purchases to build a system made up of all of those other small subsystems that will work effectively, that you will be able to, on a smaller scale, be able to lift up and take out into your driveway and point it at the North Star, get it polar aligned, and find targets to either, look at or photograph. Here at Astro Playground, I want to be able to provide an environment where videos about my experiences, videos about the things that I've learned are made available to you. So to that end, if this kind of content is appealing to you and you want to be a part of our channel, consider hitting that subscribe button, hit that like button, give us a like if you like this video. Also consider hitting that notification bell. That bell will alert you to when we have new content that's up and available. If you are in the market for equipment, I've provided a link on our homepage to Astro World telescopes. It's an affiliate link, and it doesn't cost you anything to use it. It simply gives us a small commission on anything that you buy from Astro World telescopes. We will also be more than willing to help people that are new to the hobby and are looking for advice on how to choose the kind of rig that is going to be suitable for their needs based on what kind of imaging you want to do, and also help you to try to avoid some of the big mistakes, those landmines that can blow up in your face. You don't want to spend hundreds and hundreds of dollars on something that turns out, you could have gone a different road and purchased a different piece of equipment that would have worked better, right? And now you're stuck with, something that doesn't work as well, or something that, God forbid, doesn't work at all, or won't work with your particular rig setup. It just isn't a good match. So we want to help you to avoid those kinds of mistakes. If you want to support what it is that we're doing here, and you like what the information that we are providing to you, consider buying me a coffee. Come over and support our channel monetarily. All proceeds go to furthering this channel. And we are looking forward to not only growing this channel well beyond, the 1,000 subscriber mark, and we certainly appreciate all of the comments that people offer. They are an important key element in what we do. If you see us doing something, or you have a suggestion about something that we've been talking about or are doing, that you think you know how to do it better, you have a better process, consider commenting down below. Tell us what you think we're doing right. Tell us what you think we're doing wrong. For that matter, tell us if you just think we're being an idiot.
I'm an idiot! You're an idiot!
So I encourage you, continue to image, continue to educate, and clear skies. Until we meet again, from all of us here at Astro Playground, bye for now.